Okay, well, thank you, Mark, for that. I have known you a very long time. I started out in HPC when I was a grad student in Seattle, and I went to get a summer internship with a company called Terra, who a couple of years later went on to buy Cray from SGI, and then the rest was history until now, when everything's changing again for us. And so I've been in New Zealand now for about 15 years, and I've seen a lot of tenders from Asia Pacific all over the place, and a lot of benchmarks have come across my desk. And so what I wanted to talk about today is really sort of how we view the benchmarks from the perspective of those of us who are in the trenches doing the work. I've talked to my colleagues about this, and this is sort of based on the experience of all of us. I would say that my approach is really from the traditional HPC side. I know things are changing, but there is still a lot of life left there, actually, based on what I'm seeing. But Rangan is in the room as well, so he can help out when we address the non-traditional side if necessary. What I'm going to say, I think, is basically non-Cray specific. I'm sorry, Raj. But I didn't quite realize, because I haven't been here before, how many other vendors would be in the room. And it would be really good to actually sort of compare notes afterwards and see whether what I'm suggesting sort of gels with what you see and whether I've missed out things as well. Okay. So what I really want to do in outline is to sort of talk a bit about writing RFPs, how benchmarks do tend to be used if you are interested in using them, evaluation metrics, issues such as projection and optimization, a couple of, quite a lot of suggestions from the benchmarkers from my colleagues around the world, and a couple of comments on acceptances if we get that far. So RFPs, if you are writing them, I really do take my hat off to you. It's a really challenging thing to have to do. You really have to, under pressure and probably with a lot of financial pressure as well, identify exactly what you want in the system that you're trying to buy. How do you score highly the things that really matter to you? And how do you then try to also eliminate what you don't want in order to get to the best system that's going to be best for your workload? And then how do you compare different vendors? How do you figure out who's going to score better for you? One thing is obviously to ensure that your documentation is really clear and really unambiguous. If you're not clear, then you're going to get loads and loads of questions that you're going to have to keep working to respond to, and you're going to get delays, and delays possibly lead to installation problems and even loss of funding if it really comes to the worst. I would say if you're non-English speaking but your RFP is in English, I would get a native English speaker who's good at writing to go through it before you release it. Because again, lack of clarity based around translation issues is sometimes quite disturbing. Allow vendors time to ask questions. Make sure you do answer everything. We can really help identify issues for all vendors. I know that most of your procurement models probably don't allow for confidential questions. You have to publish everything, but sometimes it can be nice to ask things that we really don't want shared with everybody. And sort of along that line, if you can release benchmarks prior to your RFP, it can really help not only us get a head start on things, but also it can help you because we can ask questions and we can maybe shake out some problems you hadn't anticipated before you actually get to the point of RFP release. And yeah, the law of unintended consequences. This often raises its ugly head when a requirement for more performance than you actually have a budget for ends up in an RFP document, especially if you're in a country where you actually can't change the requirements once they're published. If you do that, then you might end up with something you actually didn't want. As one of my colleagues said, vendors tend to get creative when they have to fit something into a package that's too small. So why use benchmarks in RFPs? If you know what you want to buy, if you're pretty much locked down on what you're going to get, then maybe you don't need them. But in general, most of us, most people here probably do. Basically, you're just trying to sort of check out what's a measure of the proposed machine's capabilities in comparison to whatever your workload requirement is. So basically, the first thing you've got to do is understand what it is that you're valuing and how you're going to score the proposals. And then I would say provide the smallest set of benchmarks you possibly can to measure that. Keep your expectations sort of in proportion to the value of the deal. You know, if it's a really small deal, we can't be doing hundreds of benchmarks, really, in reality. And then, how do we see these used? Well, you know, at its very simplest, they're used as just a hurdle, maybe to limit the number of responses that people expect to get to their tenders. Just to basically maybe eliminate a layer of people who aren't necessarily as experienced in the field. And then beyond that, you're trying to discriminate between the systems that you're offered in their capability to handle whatever the workload is that you're asking to handle. Sometimes benchmarks are just intended to evaluate the proposed hardware and are pretty straightforward. But say if you allow optimizations within the benchmarking, then you're also able to evaluate the vendor themselves and how maybe they can support you in the future if they do a good job. And then benchmarks are used to size the system, actually, that you need to run your workload as well. A couple of observations from colleagues when I was asking around. One observation was that commercial RFPs can often actually include better defined benchmarks that tend to more accurately reflect the workload, which is probably really because commercial workloads are often very well defined. The DOE labs in the US, they also are particularly good in how they're designed. They have a lot of proxy applications that they've developed over the years that really do represent their real workload, and as things develop, they're able to scale them up to the job sizes that are really going to be important to them. So those people really like working with, but if you're going to do that, you've got to have a huge number of resources. So it's not necessarily the way that everybody can approach things. Be careful with benchmark requirements that you might add because you've seen them in other RFPs and they seem like something that's easy to add. If they're really nothing to do with the purpose of your system, there's probably no point really including them. Like, you know, single node benchmarks are simple to deal with, but if you want a lot of network and that's important to you, you're really wasting your time. Similar sort of idea, if your main workload's memory bandwidth limited, include something similar to stream or weight it highly, and don't bother so much with clock-bound applications. If you just use standard applications, then you're going to get something standard in return. If you just use HPL, you'll get very similar sized systems probably. If you choose a processor based on spec, you'll get something with a high core count, but which won't necessarily actually help you run your applications. So just be a bit careful. And then there are new benchmarks coming out. There's GPCnet developed by Oak Ridge, and Cray are involved in that as well. And that's an attempt to get a measure of the ability of a network to handle congestion. I know that we're looking at that in Cray for our new network, and I know, Mellanox have looked at it as well. So that's one example of something that's you might want to have a look at on GitHub and see whether that might be appropriate for you. Now, this is kind of the most important thing that we really like to see. The first thing I look for when I go through an RFP document is where's the evaluation metric? What exactly are you asking for here? It's really important from our point of view that we understand what you value and how you are going to score that when you actually evaluate the RFP documents, the RFP responses. And this came up the other day in the meeting at Pawsey as well. We really like to know your overall scoring mechanism, like how highly are benchmarks weighted in the overall scheme of things. If there's a tiny weight to them and it doesn't really matter what we do, then we need to know how to allocate our resources and what we're going to propose to you. You know, at the end of the day, if you're going to buy a system based on HPL, then we need to understand that. So there are various evaluation metrics that we come across. I mean, these are just a few. Sometimes people just ask you to run and report a performance, and that's more of a barrier to entry, like I was talking about, for small companies. Quite often we get a benchmark test with a target time. This makes an awful lot of sense in the case where you're doing operational weather forecasting and the forecast absolutely must be produced in a certain amount of time. Sometimes each individual application is evaluated on its own, usually relative to each of the other vendors who respond to an RFP. Often you're also looking to evaluate scaling performance, maybe up to the size of the system if it's small, or up to the size of the scaling limit of the particular application. Throughput mixes can be a really good idea. If you can take a representative sample of your workload and ask for those to be run together on the entire system that's being offered, that can help you evaluate the impact of I/O and storage requirements as well within the mix of your benchmark performance. That point is from the manager, who says that that requires a lot of additional work for us, so maybe you want to drop out something if you're going to add in throughput. And then weighted metrics are actually quite a good way to do things. They're often, you see them referred to as SSI metrics or SSP, as sort of sustained system performance. So in that case, you bundle a mix of applications and kernels that are really important to you, and you weight each one appropriately for how much its priority should be set. You tend to set a target time that each one has to be run within, and then the game is to sort of minimize the number of nodes to meet each target time. And then at the end of the day, you come out with a single number, an SSP number from each vendor. It's probably easy to compare. And why it can be useful actually at acceptances is if we're bidding you future hardware which we don't have a 100% handle on its future specs yet, we can be committing to an SSP number and give you the proposed performance while being able to maybe vary each component at acceptance to take into account the fact that not everything is 100% known at the time of the bid. So these are just a couple of different examples of sort of types of metrics we see coming across. This is just quite a simple example where we had a bunch of different benchmarks, and each one was scored in isolation relative to the other vendors and had to be reproduced at acceptance. So say for a benchmark 2, we have a time to solution, and then you take the reciprocal and you come up with M2 star. So each vendor has a score M2 star, and obviously higher is better because it's. And then you also multiply, in this case, by a heavy side. So anybody who comes out 30% of the maximum is just going to get a 0. So you're kind of eliminating the people who aren't so capable at that point. Gosh, I've got to stop pressing that. And again, there are weighting as well. This was a different type of evaluation that we get in one of the countries we deal with. So for this type of example, they said we'll run 10 copies of one benchmark in a certain time with a certain weight factor and come up with a number of nodes, and then so on and so forth down through maybe 6 or 7 benchmarks. And so you come up with your node counts, and then you multiply out your node count for each benchmark times its weight factor, come up with a product and multiply by the peak teraflops per the node for what you're bidding, and you come up with a sort of BSU, a basic system unit in terms of teraflops. And then you then had to bid certain multiples of that BSU size. So that meant that what we were bidding, the system size was entirely linked to performance. That's what they were interested in. Gosh. And sustained system performance, this is a really, really simplified version, but say you have a benchmark I, you get a target time, the vendor estimates the number of cores it will take to run that benchmark in some time t that's got to be less than the target, and then you define a concept of runs per hour. So the game is obviously minimizing t by n, and then you take a geometric mean across all of those benchmarks. It gives you an SSP per core, and you multiply out by the number of cores you're bidding, and that is your single number that each vendor will provide to you. Very simple to actually compare, and obviously this can get more complicated. You'll weight things, etc. But at the end of the day, that's the basic idea. So this is kind of relevant to the next slide, but also I'm not sure how much longer we're able to put these things up. So remember Cray. So estimation is pretty much going to be essential for if we're bidding anything that's not in existence yet, or for any sort of systems that are sized bigger than what we're likely to have in our labs as any particular vendor. How do you know what we're doing? Well, I guess you look at the prior record of the vendor. Have they done this before? Can you talk to customers who've gone through this process with them before, and how has that worked out for them? I'd be looking for a good explanation of the methodology that's being used, something that you understand and can trust. I wouldn't expect to get full details of how every data point is arisen at. No one's probably going to tell you that, but at least something you can follow. Good relationships with processor vendors and interconnect vendors so that you know that the estimates are actually based on real knowledge of what's upcoming in future hardware. rather than complete guesses. And, oh God. And look for full commitments to the proposed performance at the end of the day. Be careful of applications with randomness in them. If we're really going to estimate to something, we need to know that our runs are consistent, run to run. Okay, and if we need to scale out to higher core counts, we absolutely do need to know the number of iterations that are being taken. Optimization, some RFPs don't allow it. I guess that's their prerogative, but a better choice might be to allow it, and you can actually specify guidelines, such as the types of optimizations that are allowed. You can require that the scientific validity should not change if things are optimized. You can cut down on optimizations that are specific to the benchmark problem size itself, like don't let people cache block just for that problem size. And you can absolutely ask for full details about optimizations, and you can absolutely retain the ability to reject things if you think they're unreasonable. It has to be done. Sometimes legacy apps really don't scale up very well, so it is really good if we can do that. And it also allows you to evaluate maybe the skill of the vendor at the same time. Okay, this is from my colleagues. This is stuff that I asked them. I said, well, what do you like to see? What don't you like to see? What's good? What's bad? And the nice thing was that everybody basically came up with the same stuff. So clearly these things are happening all the time. First of all, figure out, like we said, what are you asking for? Is it maximum time? Is it the fastest running job? However many nodes? Is it the maximum number of jobs on the system? Make your benchmark instructions clear. The README in the tar file quite often conflicts with the benchmark instructions in the RFP document. I can't tell you how many times that happens, so make sure that somebody is checking everything. Get your tar file unpacked and tested by somebody who wasn't involved in creating it before you distribute it to all the vendors, just so that they can check it for consistency, any instructions that don't make sense, anything missing, and you get those bugs out before you go to the vendors and you get 20 questions back you've got to answer. And just be careful with your working directory. I've had a benchmark distribution on 2 terabyte disks, which was full, and these disks were full of core files and old runs. That is not a benchmark. Clean up anything that's not required. We just want the minimum set. Supply validation requirements and make sure they are clear. That previous talk was brilliant. You see what comes out of WARF, many fields, many complicated fields, and I swear to God, this is what I had in the recent RFP. WARF output should match to within 5%. It's so meaningless, it's ridiculous, so don't do that. What's your run length? Runs that take multiple hours a day are horrible. Good benchmark doesn't run for more than an hour. That's a kind of rough guide, but that type of time frame, an hour, 2 hours, 3 hours is fine, but if they're really long, it's hard to debug. If it's going to fail after 20 hours, it's hard to optimize. And we're not spending time on your benchmarking, we're spending time just running the thing. If you do shorten the run, and the initialization portion starts to maybe overwhelm the entire runtime, consider looking at timers and only evaluating maybe the time stepping part of your run. And find a decent problem size. Bit reproducibility, obviously the output's not going to be bit identical if you run on one system and then go to another. Be reasonable about the amount of precision you're asking for. If your input data is only significant to a certain number of significant digits, don't ask for anything more on the output maybe. Just find something scientifically valid and that's meaningful for you and use that. Just say, if you want identical runs to give identical output, do say so, because I can ramp up optimization and break that all the time, but it might not be good for you. And if you do need bit reproducibility, again, make sure that A, the code will do that, but B, you ensure that we know you need that, because then we won't optimize too far. And try not to require huge amounts of binary data. It can take us like a week to get stuff onto disk in the US and ship it out to Asia Pacific, and it just wastes time. So if it's something we can upload, that's really appreciated. Just get the minimum you need to really validate that we've done the runs, we've got the answers that you need, and a post-processing tool that we can actually run before sending you back information can be a really good way around that. Try not to add too many restrictions on the way the benchmarks are run. This is sometimes done when people are too focused on the existing system that they've got. We really need to be able to run the best way on our proposed architecture to show you what it can do. So really specifying exact number of MPI rank counts and thread counts that don't map to the architecture of the processor can be actually not that useful. Give us flexibility to show you what we can do. And also, please don't necessarily request specific compilers or even specific MPIs, because again, that doesn't necessarily work for the system that we're trying to show you. Watch out for large number of commitments for no clear purpose. Just ask for numbers that are clear to you, and try not to ask for lots and lots of MPI numbers. Say the OSU OMB benchmark suite has a couple of dozen data points. When we have to estimate all of those and prove them as acceptance, it can lead to a lot of time and bother. And figure out what's important to you and ask for that. And please don't do this. Really, you are going to get a request for an extension. It happens. And then IOR, or IO. Everybody uses IOR and MD test. It's not necessarily always used well. It's hard to translate to your actual application. So if your applications and workflows are really storage limited, which, let's face it, they probably are these days, think about throughput mixes maybe as a way to address that. But if you've got somebody who's got really bad practices in your data center and you sort of end up, don't end up buying storage to suit them, spend your dollars fixing them. It's probably cheaper. And yeah. If you do look at IOR and MD test though, which I'm sure you probably will, try and give us flexibility again to demonstrate how we can get the best performance using IOR based on your interests in those tests. Don't lock us down to sort of 32 nodes, these options specifically, because it doesn't really tell you what you should be trying to find out. And tuning flexibility is always appreciated. Okay, so I'm nearly there, Mark. Just a couple of things around acceptances, because we do get involved through to the end of these processes. It's really good to understand penalties. That's not really benchmark specific, that's in the contract. But when we're talking about estimates, we really need to understand where the penalties are. If a top 500 placing is important to you and you've got a large system, it does take time to tune up. So it's good when we're planning acceptances to know that that is going to be something of importance and we can allocate enough time for it. Be a bit pragmatic about targets. If the hardware wasn't in production when we were doing the estimates, there will be some variation, which we do try to minimize and we would try to commit to. But in that case, an SSP metric that's going to average out over all your benchmarks can really work well in that situation. And yeah, if we can just finish our job before you let your users on, that's always appreciated. So in conclusion, define your workload and then design the minimal set of benchmarks. Write the requirements as clearly as you can and get them tested by somebody before releasing them. Define a clear evaluation metric and just let us show you what our system can do to make sure that you end up with the best system at the end of the day that's going to help you do your work better.